Moving on into Algebra, Chapter 7.5. So we've solved different types of linear systems in different ways. We've used substitution, we've used multiplication, or elimination, we've used multiplication to change the equations to get them into uh, in a place that we can use elimination. And so now we're going to talk about there are special types of linear systems, and let's go ahead and take a look at one here. So here's one that I have 3x plus 2y is equal to 10, and I have another one that says 3x plus 2y is equal to 2. Well, let's go ahead and let's take a look at this one, and let's try changing this one around, and let's graph this. So let's do what this one looks like if we graph it. Well, this first one, the blue line here, I'm going to go ahead and I'm going to change this, okay, and I'm going to make this into 2y. Actually, I'm going to change it into slope-intercept form. So it's going to be equal to y is equal to negative 3 halves x plus 5, okay? And really what I did is I took this and I moved it to the other side, and then I divided everything by 2. And I'm going to do the same thing for the bottom here, for the red one. So let's go ahead and change that. We're going to turn that into, that's going to be y is equal to negative 3 halves x plus 1. Let's go ahead and graph this now. Make a x and y axis here. Make the y axis here. And we'll make the x axis along here. Okay. Whoops. I want that to be red. I'd like that to be green. Okay. So that x, and here's y. Okay, so let's go ahead and graph it. The first one, the blue one, right? It starts at 5. 1, 2, 3, 4, 5. And I'm going to have a negative 3 over 2 slope. So down 1, 2, 3, and then to the right 1, 2. And I'll do that again. 1, 2, 3, and right 2. And then from here, I can go ahead and I can draw a line. And it's going to go about like that. Okay, and then let's go ahead and we'll graph the second line here. So we start at 1. And I'm going to go down 3 and right 2. And down 3 and right 2. And I can draw a line there. And so what I'm looking for here is, where do these two lines intersect? Well, hopefully, as I was doing this, and maybe even before that, you could have seen that they're never going to intersect, right? I mean, the whole idea here was we looked in previous chapters, is that if the slopes are the same, right, they move across the graph in the same way, right? They both go down 3 and right 2. So they're never going to be moving any closer to each other. And the y-intercepts are different. They're never going to intersect, right? These are parallel lines. They're parallel by definition because the slope is the same and they have different y-intercepts. Okay, we can take a look here. We can look at maybe this point and this point. We can say, okay, well, right here they're 1, 2, 3, 4. They're exactly 4 spaces away. And if I look at this next point here, they're exactly 4 places away. And this one is 4 places away. And it'll be 4 places away everywhere, anywhere along that line. Okay, so in this case, there is actually no solution. Right? This linear system has no solution because the two lines never actually intersect. Well, let's take a look at another way. Let's go ahead and we're looking at the same equation here, and let's do this one, and let's go ahead and use elimination for this one. And so we're going to add these two things together. Again, I like to add everything. It makes my life easier, I think. So what I will do is I'm going to change this negative, negative, negative. It's kind of like I just multiplied by -1. And so I just made all of these the opposite. And now that's this way, when I add these together, I have 3x and negative 3x, and that's going to be 0, and plus negative 2, or 2y and negative 2y is 0, and 10 and negative 2 is 8. And so this is 0 is equal to 8. Well, that's not true. And if you remember previous chapters, when we get something that looks like this, and you have 0, or you have two things on opposite ends that don't equal to each other, it's just impossible. So in this case, there is no solution. Okay? So two different ways to kind of get to the same answer. One is by graphing. This was one of the first ways we learned how to do linear systems. And the second, by elimination. Let's go ahead and let's take a look at another line here, okay? So that second one is actually already in slope-intercept form. So let's change the first one, and let's turn that one into slope-intercept form as well. So I'm going to take this, and let's see, I'm going to get negative 2y is equal to negative x minus 4. I'll divide everything. All right, we'll go ahead and change this one more time. We're going to divide everything by negative 2. So I get y is equal to 1/2 x plus 2. Okay, and let's go ahead and if we graph that very quickly. Okay, let's make a y-axis here and an x-axis along here. This is x and this is y. And if I graph the blue one, we'll see it goes up 2, and then I have a slope of up 1 over 2, up 1 over 2. And I have a line there. Okay, there's my blue line. And let's go ahead and graph the red line. Okay, and I'm going to start at 2, and I'm going to go up 1 over 2, and I'm going to go up 1 over 2. And you'll notice, I'm hoping as you saw before I even began graphing, is that these two lines are right on top of each other. In fact, they are the same line. And if they are the same line, then the idea here is, where do they intersect? Well, they intersect everywhere, right? So this is one where you'd have all solutions. Okay? They're the same line. They intersect everywhere, right? Everywhere on that line. Okay? Well, again, let's take a look and let's try using another variation here. And so looking at this one, I could use elimination. And actually what I would do is I would think about using substitution here, because I've already have this set up that y is equal to this. So I can just plug it in right there. So let's try it. Let's do x minus 2 times 1/2 x plus 2 is equal to negative 4. Okay, well now let's simplify, and I get x minus, well 2 times 1/2 is 1, so x minus x. And then negative 2 times 2 is going to be negative 4 is equal to negative 4. Well, x minus x is 0. So I get negative 4 is equal to negative 4. Well, that's true. So that means no matter what number I plug in there, I'm going to have all solutions. All solutions. And let's just go ahead and let's try something. Let's pick a couple numbers here. So let's just try if x is 0, right? If x is 0 here, y is going to be 2. Okay, well, if x is 0 here, let's see, negative 2 times what is negative 4? Well, negative 2 times 2, so that does work. Well, let's try another one. Let's try something a little bit bigger. Let's try x is 10, right? So if x is 10, 1/2 of 10 is 5. 5 plus 2 is 7. Well, here, 10. 10 minus what is negative 4? Well, then I subtract 4, so I get negative 2y is equal to negative 14, right? I get negative 2y is equal to negative 14. Well, y is going to be equal to 7. Okay, well, that's true there. It was true in two different places. If it's true in two different places, it's going to continue to be true no matter what I put in for x or y. All right, well, let's do another one idea here, okay? Let's instead of solving this, let's put this into a place where we can sort of decide how many solutions are this system of equations is going to have, okay? So I have two equations here. Let's try to figure out how many solutions it has. How many solutions? How many solutions are there? Okay, how many solutions does this have? Okay, well, let's review. All right, we know that there is one solution, right? When they intersect. Lines intersect. Okay, and then we just reviewed that there'll be 0 solutions when the lines are parallel. And then we know that there's many solutions, or there's going to be, we'll say, an infinite amount of solutions, right? Infinite amount of solutions when lines are the same. So if we can find if the lines are parallel or if they're the same. Okay, if we can check these two things and neither one is true, then by process of elimination, it has to be one solution. Okay, well, we can figure out these two things, okay, based on either slope and the y-intercept, or we can use elimination or substitution. Okay, we can use either one of those ideas to decide how many solutions there are. Okay, well, let me do this. I'm going to take these ideas. I'm just going to throw them off to the side. Put them down here. I'm going to shrink them down a little bit. Okay, so let's go ahead and take a look at this. Okay, if I'm going to graph this, let's do this. I'll put this into slope-intercept form. So this one I'm going to make y is equal to negative 5x minus 2. Okay? That's what I did there. This red one, I'm going to say, all right, move this negative 10x to the other side. So I get negative 2y is equal to 10x. Okay? Plus 4. Divide everything by negative 2. Negative 5x minus 2. Okay? Now looking at this, slope, slope, same slope. So they're at least parallel. Same intercept, many, right, solutions. Okay? Or more than one solution, we could say also. All right? It's going to have more than one solution. Okay? Actually, I'm sorry, it really has an infinite amount of solutions because it's going to intersect forever and ever and ever. Okay, well, that's how we would do this using slope-intercept. Let's go ahead and try doing the same thing using elimination. Okay? Well, I'm going to take this first one and I'm going to multiply it by 2. Okay, so I get 10x plus 2y is equal to negative 4. Okay, and I'm hoping that you can look at this and you can look at this one and you can say, oh yeah, these are pretty much the same. Right? They're just opposite of each other. Okay, when I add these all up, I'm going to get 0 is equal to 0. Well, that means infinite solutions. Okay, well, let's do one more. Why don't you go ahead and you try doing this one, and you tell me how many solutions you think this one has. Pause the video and go ahead and do that now. Okay, hopefully you had a chance to do that. In this case, this one looks to me like it might be a little bit easier to use for elimination. Because I can either eliminate the y's or I can eliminate the x's. I would choose to eliminate the x's only because I can have this one is positive, this one is negative, and this one is positive, and I can multiply this by 2 to get to 12. So I'm going to multiply this one by 2, and I get 12x plus 4y is equal to 6. Okay, and this second one I'm going to leave the same, so I get negative 12x plus 4y is equal to 16. Okay, and now I'm going to go ahead and add these two together. Okay, and when I add them, I get 8y is equal to 22. Well, now I know that there's only one solution. Okay? Because both of the x's and the y's weren't eliminated. If both of these had been eliminated, then I would just look to see if does this number equal this number, and if it does, it's infinite solutions. If this number didn't equal this number, if this was just a, let's say 8 is equal to 8, infinite solutions. If this said 8 is equal to 0, then I would have no solutions. Okay? So this is just a quick way of you being able to decide how many solutions a linear system will have. Okay? And as you get better at these, you'll just start to be able to look just at the beginning, and you won't even necessarily have to do this whole step. You can sort of just look at it and be able to decide. And of course, you'll need to be able to say why, justify your answer. But a lot of times you can do it just by looking at the two